All right, so what exactly is projectile motion? Well, projectile motion in the simplest form is essentially free fall. So remember, that's basically like an object, okay, being launched vertically into the sky or even launched vertically downwards, and it does something like that. Now, I want you to imagine that I'm going to repeat this, but now I put this ball on a rolling cart, right, that's traveling at a constant velocity. So what's going to happen is that it's still going to do this, but because of the constant velocity, this up and down motion is going to be spread out horizontally. And so essentially, I'm going to do this, but I'm going to move my pen up, move my pen from left to right now, and you end up doing something like that, which kind of looks like a parabola. And this essentially is what projectile motion is. It is, well, free fall, okay, plus some constant horizontal velocity. Let's call that Vx, right? And I think the key term that we're going to introduce here is called the independence of motion, meaning that the free fall motion, or we will now call this the vertical motion, and the horizontal motion, which is constant, do not affect each other. But they kind of add up to give you something like a projectile. So let's get a little bit more technical now. So in essence, when we think about projectile motion, what are the conditions for projectile motion? Well, there has to be some constant acceleration, and you have to launch your object in a direction. Okay, let's write this in a direction that is not parallel to this acceleration. So in the simplest form, we think about, well, free fall, the acceleration is g, downwards. So as long as you don't launch your object vertically upwards or vertically downwards, you should see a projectile motion being formed. Okay, so for example, if you launch an object at an angle like this, you expect it to go whew, something like that. Beautiful. So that essentially is what projectile motion is all about. Now, we're going to look at some nice little features of this. So I'm just going to draw a ball that's being launched at an angle, and I'm going to take some snapshots of it. It probably looks something like this, okay? All right. So this is the up motion, that's down motion. Now it's a little bit too big. So what I can do, I can shrink this a little bit so that it's easier for us to see. And it should, okay, I'm just going to make this as even as I can. Now, if you look at what's happening here, the horizontal velocity should not change regardless, right? It should be constant throughout. So Vx is constant. But if you look at your vertical velocity, it might start off pretty big, then it gets smaller and smaller. It's 0 up there. And then after that, it's going to start to go in the opposite direction. Okay, so these are some features of the projectile motion. So Vy is always 0 at the maximum height. And something else that's quite interesting is that if I compare this ball on equal vertical heights, so let's say here and here, the vertical velocities should always be equal in magnitude but opposite in direction, right? And that's also a feature of free fall. So that's all for some of the basics of projectile motion. We'll talk about how to analyze it using equations in the next video.